Alright, today we're going to be doing exponential translations and transformations. Okay, this is talking about the graph of an exponential function, that little exponential graph that goes up and increases or decreases very quickly. We're going to talk about how it moves and how it looks like in the function as compared to the graph that it has. So the first note that you'll need, we will use the letter K and H to represent the transformations of the function. Okay, when we're talking about transformations, we use, just like we use variables for anything else, we're talking about K and H. There are going to be the vertical, which is up and down, and horizontal translations and transformations that happen on the graph in the generic function. Okay, this again is my generic function for my exponential graphs. I have a times b to the x. This x is an exponent, which makes it an exponential function. This is always just the parent. They call it the parent function. Because it's the first thing that you always start with. And then based on this parent function, we'll either add or subtract k or add and subtract h as we go along. You'll see that in the next part. So that is basics. Ways an exponential function will shift. Okay, the shifts of the graph will have, one is the vertical translation. When the graph, the function itself, f of x or y, whatever f of x is equal to, is added with a k, so some value will be k. So if it's added, if 3 is on the end of it, then it's going to shift up 3. The vertical translation for f of x when it's minus k, if it's decreasing, then it's going to be going down. So the vertical translation when it's added at the end, this is all at the end of the function, and there's a plus and some value, some number, then it's going to shift up. Let's see if I can write. Okay, it's going to shift up. Now, if there's a minus some value at the end of the function, it's going to shift down. Okay, so I would write these out just to help you know plus means up, minus means down. Because when we get to horizontal translations, we have f of x plus h inside the parentheses. Now, when it's inside the parentheses, this means that the x value is going to be added. So say when you plugged in x for 2, so we're raising it to the second power because back to the original function. You need to know the original function. Say our x was 2, like it was for 2 years sometime, but we wanted to see what happens when we add another year to it, or we add 2 years to it. So the h would be increasing our exponent. When it increases our exponent, it's going to shift left. Okay, so when we have something in parentheses, you always do the opposite of what you think it might do. Normally we would think positive would shift it to the right like it would, but because it's inside parentheses, it's going to shift left. So if the positive inside parentheses, that's important. When we have these things in there, when it's a positive sign on the inside, then it's going to shift to the left, not the right. So the opposite is true when we have x minus h, that's going to shift to the right. Okay? So those are just some basic kind of summaries that will help you as you go along. You can always refer back to these 4 things to help you know, okay, is that shifting up, down, left, right, if we're ever doing an activity or if you're ever doing homework. You can always refer back to these. These are your notes. This is some important stuff that you're going to need to know before we move on. Okay, so that should be able to get all that down. Alright, the next part. Take a little bit more notes. Yeah. Okay, this is talking about the actual graph. When looking at functions on a graph, okay, so this is x, y axis, all that good stuff, little lines, coordinate plane. We always count the shift starting from the y, or using the y-intercept or initial value. Okay, so whatever my y-intercept on a graph, you will have your xy axis, and that function, and this is my function in blue, that function is going to cross the y-axis at some point. Well, that right here is where this dot is. That's my y-intercept. From here, that's the parent function. This is the original function. Now, if I ever see a shift, so say the next function is drawn like so, with the dotted line. It models the same numbers, but it's been shifted down to where it crosses the y-axis, down here. We're going to know that because we see that the y-intercept has changed. the graph, the actual line itself looks the same, but our y-intercept here changes. So that's how we count based on that k value. This would be a k value because it's going down on the y. It's a vertical translation going from here down here. So it would be a minus k at the end, minus some value. There would be a number, you can count the lines to see it, okay, it went down five spaces. That would be your k value. It would go down 5. Okay, so that's when we're talking about graphs. You'll see a lot of graphs when we model real-world situations later on. Okay. Let's see what we got. Examples, okay? How does, and you don't have to copy down the whole sentence, but you do need the two functions. How does the graph of f of x equal to 7 raised to the x power, so 7 raised to the x, compared to the graph of g of x? So that tells me it's not the same graph, it's another function. We have g of x equal to 7 raised to the x plus 2. Okay? So you need this function and you need the g of x function, which I wrote out here as well so you can see them. Okay, if I look and I just put them on, I stack them on top of each other to see the differences. Okay, the first value for f of x and for g of x is 7 to the x power. That's the same. But if I keep looking, I have plus 2 here. Because that's plus 2, this is the k value right here. When we were talking about in that first slide, if we have a plus k, well my k value is 2 here. Because it's plus 2, it's going to shift up 2. To answer the question, how does the graph compare to the graph of g of x? It shifts up 2. So this graph is going to be higher on the y-axis than the normal parent function. This was the parent function, f of x, and it's going to shift up 2 because it's added 2 to the end of it. Okay, so that is just a quick, easy question that they may ask you. Okay, you have to know the background before we can go into depth with word problems. Again, don't have to write the whole thing. How does the graph of f of x equal to 4 to the x power compared to the graph of g of x equal to 4 raised to parentheses, and this is important, it's inside parentheses, x minus 5. Okay, so I wrote them again, I stacked them on top of each other. If I look at f of x and g of x, they both have a base of 4. But my exponent, I don't have parentheses here, I have parentheses here, so I need to look inside of that. It has x minus 5. Now again, inside parentheses, you do the opposite of what you might normally think. Minus means I'm going to the right. So this graph would shift to the right 5 times on your coordinate plane. You would just count 5 spaces over for every dot that you had. So if you only have one dot where the y-intercept was, you just count to the right 5 times. Okay? So that's very quick and easy. If you know the important stuff of h and k, so inside parentheses, it's going to be the opposite, and at the end, if it's plus, it's going up, if it's minus, it's going down. If you know the difference between all those, you should be good. It's very simple, very easy. Kind of common sense, but common sense isn't always common to everybody, so we're just clarifying that before we go into activities with it. Alright, so here is the graphs that I was talking about that we see modeled. Y'all did some graphs with your hot air balloon, the weight of the baby, I forget the other word problems that we did on the big post-it paper. But you've done some graphs with the exponential. We're going to continue doing some. This is the parent function. F of x equals 2 times 3. 3 is my base raised to the x. It's a generic one. We locate the y-intercept. The y-intercept is at 2 because my initial value is 2. So my y-intercept is always my initial value. Tie those two things together. So I know my initial value is 2. But if I go to f of x equal to 2 times 3 to the x minus 1, something's going to change. Here my y-intercept was 2. Here my y-intercept is 1. Now if I go draw the parent function on top of this, you'll see a difference. The parent function started up here and increased this way, where it crossed the y-axis here. Now if I compare those two, I can see that the parent function in blue is above this, and it is above it by 1 time. So from the parent function to the new function, it has gone down one space. So that's why we have the minus 1 here. I just wanted you to see the visual representation of the minus 1 or the plus or some value. Whenever it changes up here, there is a change that's happening on the graph, and you need to be able to understand the concept of what's happening here visually on a graph. Okay, so when it has minus 1, my intercept went down 1. So every other value, if you can see, it all went down 1 spot. And we know that for sure by just looking at the y-intercept. Okay, so that is the graph of the two functions, and that is it. So that is all the notes for translators and transformations. We'll talk about translating and transformations in quadratics and also in linear functions later on after we get through everything that we need to do for the EOC.